Okay, I want to talk about this stuff before we get started on the presentations. Because really the answers, they should all be yes. There should be no no's. I can explain what RAM does, and is for, and how it works basically. Okay, so let's see. RAM stands for what? Random access memory, okay? What is it for? And what's it do? Basically. Okay, it stores information and code while the CPU is doing its computations, okay? So it's a storage place. It's your notebook that you use to write down all your notes in while you're thinking in the middle of class so that you'll remember them later and you can refer to that information later, okay? Think of it as a notebook for the PC, okay? How it works basically is the CPU writes to it, reads from it continually throughout its use of the code, whether it's the operating system, whether it's the programs that it writes, whether it's the data that you're saving. The CPU is continually reading and writing from the system RAM. Okay, so it's got two kinds of RAM, right? We got the cache, which is RAM on it that it has, that it comes with, and then we've got the system RAM, and we know that it first tries to use its cache because it's faster. Is cache static or dynamic? Oh, you were right, and then you were wrong. Static, right? RAM cache is static. We said that static RAM is faster, more expensive. It doesn't have to be rewritten. The difference between static and dynamic RAM. Static RAM, I put something there, and it's there when I go back. It's still there. Okay. Dynamic RAM. So think of your notebook as static RAM. Okay. You write it down. It's always there. Dynamic RAM means I write it and it will be there for a millisecond, and if I don't write it again, it will go away or begin to get corrupted, more likely. So dynamic RAM is written over and over and over again, thousands of times a second, because it just doesn't stay there. It's not as fast as static, but it's far less expensive than static RAM. Okay? So our CPU cache is static, never rewrites that, but our system RAM is dynamic. Everybody knows the difference between RAM and ROM. Great. I can define and explain what dual channel memory is. This was in your assignment for reading. Basically, dual channel memory means that it cycles the reading and writing of information between these sticks so that it works in sequence together. Okay? So it might be writing to this one and reading from this one, and the next loop around it might be reading from this one and writing to this one. And since it's kind of going like this, it does it slightly faster. It makes the system run a little bit faster. Okay? So multi-channel memory basically may have the same amount. You may get 2 4-gig sticks or 1 4-gig stick. You still got 4 gigs, but if you're working with a multi-channel memory, it's supposed to be able to access and use that faster. And in some computers, like I think it's this one, if you even put in the memory wrong, it's going to say, if you put this memory in differently, it would run better. Something like that. It says it in a way that it doesn't make sense to anyone, but that's what it's trying to say. These memory DIMMs not put in optimal configuration. Something. Okay? Meaning, you've got dual channel memory and you just put them in slot 1 and 2 instead of 1 and 3. And you have to put them in the right slots. And usually in a dual channel system, most of the time they're colored. So you got a slot here and a slot here and then a slot here and a slot here to say, hey dummy, put the same colored ones in together. Sometimes the coloring, these are all the same and you get one black, one white, one black, and one white. The only difference is the little tabs on the end. Okay? And that's saying this goes with this and this goes with this, but these are all maybe gray or black or whatever color it is. So if you looked at your own motherboards, you would see something differentiated. I've never seen one that doesn't have, if it has dual channel or multi-channel, I've never seen one that didn't have some way to differentiate what they are by color. Okay? I can explain the L1, L2, and L3 cache. That's from last chapter, and we read it today. So L1, L2, and L3. It's cache, right? It's memory for the CPU, and the difference is if I've got, and this is a very oversimplified concept of it, but if I've got I'm going to say a dual core CPU, which meaning we have one CPU with 2 cores in it. So it still looks the same. When you put in a CPU that's got 8 cores, it doesn't look any different than a CPU that's got 1, okay? You still only see the 1 die. And then there's stuff in there, right? This is let's see, what is this one? This is a dual core, it's core 2 dual, okay? So there's 2 CPU cores underneath this heatsink, okay? So it's kind of like this one. An L1 cache, it will say that in the specs, L1, 128 kilobyte, L2, 512 megabytes, L3, 2 gigabytes. No, kilobytes and megabytes, that'd be awesome. Is that something like that? Meaning that each chip has L1 on it, and each chip has 128K, and these are small numbers. These are in kilobytes and megabytes. Okay, and then it's got a shared L2 of 512. Usually you don't see kilobytes, and it also has a shared L3. See, I put L2 closer. L2's closer to the die. L3's further away of 2 megabytes. Now, usually you see L1 and L3 or L1 and L2. Occasionally you see L1, L2, and L3. Okay, but it all depends. But the difference is not how it works. It all works the same. L1 is faster because it's on it. L3 is the slowest because it's further away. But L3 is shared, so most CPU manufacturers. Let's see if I work even better today. I did not switch my batteries, and it's probably going to work just as bad. No, it's working fine. Okay. So let's see. I'm going to go. I'm just going to go to whatever processor and just look at one. Look at that one right there for $339. Let's see if the specs are down here. Right there. And this one's got only L2 and L3. So the L2 is per on this one. So it's a 4-core. So each one of them has L2 and it's off, so it's not shared. So in this case, if we were drawing this one, we'd have a 512 and a 512. Yep. So the L2 is per core, not shared, but it's not on the die. So it's not L1, and then it's got shared of 8 megabytes somewhere else off that they each share. Okay. So in most cases, they've got their own cache somewhere, and I will tell you, sometimes L2 is shared and sometimes it's not. Anymore, most of the time it's not. In many cases, you're going to see no L1, L2, and then L3, and this number is getting bigger, and they're getting more into sharing. If we go to a, let's see if we can find another one that's like quad core or something. Okay, this is 6-core. So same thing, this one's got L2 is per core. And that's why it says it's got 6 times 256, and then it's got a ton of L3, which is going to make this one run way faster than the other one. Because it's got so much more, it's got almost double the amount that the last one we looked at. I didn't look at the speeds of the CPUs themselves. Okay, question? Is that clearer? Okay, so it's just memory that the CPU used, or L1, L2, 3. Okay, explain what error checking and parity. Error checking is code that checks whether memory has error every single time it's read and write, and parity is the way that most of them check. And I showed you how it does parity every single time it writes. Oops, every time it writes, there are 8, 3, 4, 5, 6, 7, 8. There's 8. I should have just done it better, but anyway, 8 normally bits in a byte every time it reads and writes, and these only have zeros and ones And if it has parity, it has a ninth one. So it costs more because now you have another ninth amount of memory that you're paying for. And so as it's writing in here, it's writing at zeros and ones. Okay, and then it goes and does a parity check by going, how many ones do we have? If it's even parity, 1, 2, 3, 4. So if it's already even, it would put a 0 in there. And if it does a parity check and that was odd, it would put a 1 in there to make it even. If it's parity even. Okay. The point is that the memory is completely different than non-ECC. Can't put ECC RAM. Physically you can, but you can't put it in a motherboard that doesn't take it because it doesn't know what to do with this. And likewise, you can't put non-ECC RAM in a motherboard that takes ECC because it's continually looking for this and it won't work. Okay? It's slower, it's more expensive, it's generally for servers only. Okay? It is for servers only. But that doesn't mean servers have to use it. We have one server in our entire district that uses ECC RAM because it's slower and I don't want it to be slower. And if that machine had to reboot, it would not end the world. Okay? Let's see, there we go. Okay, explain what CAS latency and RAS latency are. We talked about that in class. So, 1, 2, 3, 4, 5, 6, 7, 8, yay. Okay, so when well, I'll just write it where it is. I'll live right there. So every time it writes its information, it's writing its information in this table of memory, right? And every time it writes, it's writing zeros and ones. Okay, so it's writing bits or bytes of information in bits in spots in the memory. That's what it's doing every single time it goes through and rewrites that. It's writing this information. And the CAS latency, or CL, or the RAS latency, RL, and you might see it CAS, RL. These are the delays to write, okay? So it means that it takes, if the CAS latency is 9, where the RAS latency is 9, it means it takes that many cycles of the motherboard to write the information. Okay? So it doesn't just go to the memory and say, look, you're there. Because it's writing and rewriting so many times, because it has to rewrite it all the time, there's a delay in how long it takes to get the information correctly written into the memory as that information goes around the motherboard. Okay, so the CPU's talking to the memory, but it doesn't just go, okay, here's my CPU on my motherboard. I'm oversimplifying this. Okay, and we've got which bus route goes to memory? North or south? North, okay, so again, oversimplifying this. This is my video card. Okay. So in order to write to RAM, the information goes in those packets around the motherboard, and we're going to say it's 2100 megahertz motherboard. Okay. So that's 2100 million cycles per second. Okay. So in every second, this packet goes around 21 million times. It's going pretty fast, okay? And it's going so fast that the bus doesn't stop here long enough to write all the information. Think about it like that, okay? You've got 20 kids on the bus that need to get off. Bus driver stopping for 1 second. One kid gets off. The door's open. He stops, and Lane jumps off. Okay, and then he goes around the bus route, he comes back, and Brooke jumps off, okay? So only so much information jumps off the bus to get in the stick of RAM. And in order for it to get off the bus, it has that latency, and I'm going to use 9, your numbers or whatever, okay? So if it says the latency is 9, it means it stops so briefly, because it's doing 21 million cycles in a second, stops so briefly that it's going to take 9 trips around here, which when you're making 21 million a second isn't like a big deal, right? But it's going to take 9 trips around there before the memory is written or read to the thing. Okay? So that's what latency is. It's the delay to get all the kids off the bus, because Mr. Poole is a cycle bus driver, and he only gives us 1 second to get off the bus, and I have to be standing in the doorway, he stops, he kicks me in the rear, and then he moves on. And then I got to wait for him to come all the way back around to my bus stop again, because he's a terrible bus driver. Anyway, I'm not a bus driver. So that's what latency is. It's just, this thing is going, this packet's going so fast, it just can't stay. This memory can't write fast enough. That's why it has latency. It can't write fast enough to itself to get the information off of here, because it's going by so fast to get it written down. So it takes 9 trips before the information is written down. So it's got a latency or a delay of, in this case I'm saying 9, it's whatever you found on your specs. So if I was to go here and do memory, we'll look at one real fast. I know we're going to get a chance to see all yours in a second, but I really wanted to go through this and answer some of the questions before I ask some of these questions. And you go, I don't know what that was. I never understood it, Mr. Poole. You're crazy. Okay, so this is a perfectly good business one. It's 2x4, and we said the business PCs were going to get 8 gig of RAM. In this case, it says clearly our cast latency is 9. Okay, and you in your reading you read what all these different numbers for, but the first ones are cast latency. Okay, and usually, I'll say usually, because I don't know if I've ever seen where cast latency and RAS latency aren't the same. Okay, and since they're the same, why would you put cast latency and RAS latency? It's the same number. We just all look at one thing when we talk about that. Because one's right in the columns, one's right in the rows. Okay, so it's the column latency and the row latency. Theoretically, it could be different. I don't know that I've ever seen it different. Theoretically, it could be, but we all just look at the cache latency or the column access strobe latency. Okay, it's just saying when I write my columns, this is how long it takes. When I write my rows, this is how long it takes. And usually they're the same number. Okay, so it's saying as I go around here, and I'm looking at my RAM, it takes so long to write this way and so long to write that way. So many trips around the motherboard to do that. But that's what, it's a delay. It's just the delay it takes because it's going so fast. So if I wanted to know the speed that it writes the RAM, the actual speed that it writes, if I had, well, we're going to use this one. Let's use the one we're looking at. It's going at what speed? What megahertz is this one going? 1600, okay, and we've got a latency of 9. So we've got 1600 megahertz, which equals millions of cycles, CLES, per second, okay? And we've got a cast latency, which equals 9 seconds per, no, I should say 9, not seconds. Bad, Mr. Poole. 9 cycles per write. Right? It takes me 9 cycles around to get one write. Okay? So if we wanted to figure out how many writes per second, we would have to put these two numbers together. Okay? So if I'm cycles per write, and I have millions of cycles per second, if I multiply those together, would I get the right answer? No, because then I'd have cycles squared per write times seconds, right? I wouldn't get rid of anything. So how do I get rid of, I really want writes in seconds is my final thing, if I want to know how fast it writes, right? So what do I do? How do I, if I do 1600 divided by 9, and then I would get my second, and then I inverse that, right? So I'd get writes per second, no, per cycle, sorry. And this is cycles too. And then I kill my cycle, and I kill my cycle, and I get writes per second. Yes, that's the correct answer. Okay, so if I did that, I'd be 1600, remember this is 1600 millions, okay? So I'm gonna say 1600 millions divided by 9, and we're gonna get how many writes we get per second, right? Yes, we're gonna get how many writes per second. So I would have to use the calculator for this because I'm not gonna pretend. Okay, so if I use my calculator, now we're gonna get writes per second. If we wanted seconds per write, we just invert it, right? So I'm gonna do the opposite. I'm gonna say how long does it take to write it. So I'm gonna do 9 divided by 1600,000,000. So it takes that many seconds to write the memory. I inverted it because I wanted to know actually how many seconds per write, not how many writes per second. If I inverted the thing, right, I'd just get a humongous number and say how. But I want to know, so if I wanted to compare memory, numbers to numbers, this is the number that actually tells me the most, right? How fast does it write the memory? And it's writing it in, oh my gosh, so this is a thousandths of a second, right? That's a millionth of a second. So it's writing it in 5.6 billionths of a second. It's pretty dang fast, okay? But this number right here now is a quantifiable way to compare one of them with another one, looking at the clock rating and the speed, which is why if this number is bigger, we have a problem, right? So if it takes more cycles, we're looking at 1600 megahertz RAM, and one of them has a CAS latency of 11, and one of them has a CAS latency of 9, this number is going to go up, okay? How much does it go up? Let's see how much it goes up. So we got 5, you just remember 5625, okay? So if we took the same numbers, and divide it by 11 instead. No, we would divide 11 by that number, right? We do it backwards. So 11 divided by 6. 0, 0, 0, 0. The number is 6875. So it's between 5.6 and 6.8. How much faster is it? I'm rounding here. So it's almost 20% faster RAM from that 2 extra cycles it has to do, okay? Because it's 82%, 18% faster, okay? So that CL number really does make a big difference. I mean, if you're saying it's 82% different between the two, or 18% difference between the two for just 2 cycles difference, it can add up. That's why you want to look at that number. But if most people don't know that, most of the time they don't write how long it takes to write, because first of all, you'd be looking at it and then be like, e to the negative, what, 5.6, e to the negative 12th? And be like, oh, that's really small. If people even know what e to the negative meant, right? Because some people have forgotten their math. Since you guys all know what e to the negative means from math class. Okay. Yes? Okay, yeah, 10 to the negative, yeah, right. Okay, but some people don't know that. Okay, so back to our conversation. So that's what that latency mean. It really can, if you wanted to take all and do all the math, you can convert it to how long does it take to write memory in this particular stick of RAM and on this particular motherboard. Because remember, they kind of sync up together. So it doesn't matter how fast your motherboard is, if your RAM is slower, it's going to write at the speed of the RAM. So that information that goes by only gets off the bus so fast, which is why we say it syncs up. Okay. How are memory speeds measured? I just said one of the ways, that's the hard way, right? Usually it's just measured in megahertz. People just look at it and say, what's the megahertz, but the clock rating matters. And that's why when we talked about what does fast mean, well, megahertz means a lot, but if you've got one that's 1600 megahertz and a CL of 9, and you've got one that's 1200 megahertz and a CL of 6, which one's faster? There's no way to, I mean, you could say, faster memory is faster, but it doesn't really mean that. Because if you went and did this math, it could be they're exactly the same. And if you watch, there's some YouTube videos comparing does faster memory really mean that much of a difference in your computer? And they said no. If you buy 1600 megahertz and you buy 2100 megahertz, the clock rating is enough different, the CL is enough different, that it's almost the same speed of RAM. So if you're looking at now, they're both DDR3, so they're both the newest generation, and they're both relatively fast. So sometimes people throw away money trying to get the fastest memory they can in their system, when really, because it takes more cycles for that memory to read, because this bus can only handle writing so fast, the memory can only handle writing so fast, it doesn't quantify as, well, 2100 is always better than 1600. Maybe. Maybe it's pretty darn close. I'm sure it's faster, but is it immeasurably faster, or is it just like, okay. It wrote, 1/10 of a billionth faster of a second. Okay, maybe we can catch it. I don't know. I can tell what memory to purchase for a specific motherboard. Everybody said yes, great. I can use the online memory tool to analyze a PC. We haven't done that yet, so we're going to do that after we're done today, as well as testing memory. I can tell the difference between SD-RAM and DDR-RAM. That's old. I should take that off of there. SD-RAM, DDR-RAM is SD-RAM, by the way. It's the next generation of SD-RAM. SD-RAM had 2 notches in the RAM chip, and DDR has 1. It used to be a factor because we used to have SD-RAM PCs, and we used to have DDR PCs because we were overlapping, but we're really doing it. We're just take that now. I can install memory in a PC. You guys have done that multiple times. When we torn our PC apart and take it out and put it back in. Shame on whoever said no. Remember, we go like this. Kick. Not very well. Okay. I can test memory for errors? No, but we're going to learn how to do that. Okay, we're done. We're going to go through and start our presentations. Everybody got their rubrics done? I'm going to stop recording as we do our presentations. And I know some of them are Google Docs, so I'm going to go ahead and sign in to Docs so that if you click on it, I'm already in there and it should open up for you. Okay, going down to our memory, yes, memory. That's where we're at. There we go. PowerPoint project, view one submitted. What? What? There's no link? I don't have a link right there. Did I not do the multiple way to do it? Did you get right there? See? Oh, I didn't put it in there.
Yeah.
My bad. I can't even throw a stone there. No, I should have had it as a multiple assignment so you could edit, and I need to.
Yeah. Well, that's okay, because Lane said he's the one person.
Okay, I'm putting an update here so I remember to do it on the assignment after we're done. Lane, you ready?
Sure.
Since you're the one here, and then we'll go to the other ones after that. Oh, I want to stop recording.